Good good day, ladies and gentlemen, and we are back again together. All right, looking at the multiple choice section for paper 2 for the recent prelim that was written. Okay, please just make sure you're part of the family. All right, and just make sure that for those of you who need assistance with mathematics or physical science, please just send me an email, and my email address is info@mlungisinkosi.co.za. All right, so let's get right into it. Okay, and again, ladies and gents, just before we start with the multiple choice section, I'm actually trying to show and prove to you that multiple choice, is not something that you dive into and just pick any random answer, right? You have to be intentional about your responses. So we just cannot close our eyes and hope that we land at the correct answer. There's a process in which we pick our answers there, right? And it's a phenomenal way to actually revise what you know and all of that. So yeah, and preparation for your final exam, please make sure that you do as many multiple choice sections, and just do your multiple choice, and try to answer it for yourself. And mark it for yourself. See which responses you understood and which you don't. And obviously, you can always just refer back to our lessons, just to jog your memory and just remind yourself of what you already know. Okay, so let's get right into it. They say, which one of the following is an alkane? So we know alkanes, right, should have the general formula CnH2n plus 2. Okay, if you don't remember that, please go back to our playlist on organic chemistry. You should be able to be helped there. I think the one that fits there, we won't waste time much with it. So the one that fits that general formula is the last one, which is D. So the correct answer there should be option D. Okay, so they say esters are formed by a reaction between two organic compounds X and Y. Now, let's keep in mind, how do we form esters? We know this is when we take an alcohol, right, that reacts with a carboxylic acid, right? So they say the functional group of these compounds are, so alcohol, we know that what should be the functional group of alcohols, right? So that should be the hydroxyl group, right? That's the hydroxyl group. And what about carboxylic acids? That's going to be the carboxyl or carboxyl. I don't know which one you prefer to pronounce it. Carboxyl and carbonyl, right? In this case, it's going to be the carboxyl group. Okay, so I think A should be the correct answer there. So compound X should be the alcohol, which is got the hydroxyl group, and then compound Y should be the carboxylic acid, which has the carboxyl group. So in this case, this should be A, right? Okay, remember carbonyl, that's C double bond O. Okay, that would be applicable for what do they call those? Ketones. Yeah, ketones. C double bond O, that should be ketones. All right, moving right along, they say when butane is subjected to high temperatures and pressures, the following reaction takes place. Okay, so what they do is that they now take butane and they form methane and something else. So this would be a typical cracking example. Okay, now think about it. So butane is C4H10. Okay, and I now am forming something with CH4. Okay, that would be methane. So what would be compound Y? Okay, so if you look at this, I had 4 carbons here. I've only used 1, so Y should have 3 carbons. Okay, I had 10 hydrogens. I used 4 there, So Y should have the remainder of them, which is 6. So this is C3H6. This is definitely an alkene, right? They say which one of the following represents Y. Okay, so I'm going to look for an alkene there with 3 carbons. Definitely not A. I think my answer should be B. You can see there should be a double bond between carbon number 1 and 2. It doesn't have the maximum number, so my correct answer there for 1.3 should be B. Okay, right. Let's go to the very next question. All right, so in 1.4, they say a hydrochloric acid solution of a concentration of 1 mole per cubic decimeters is added to excess powdered magnesium at 25 degrees Celsius. So in this case, we know that our magnesium is powdered, okay, and our magnesium is in excess, all right, and the concentration of our acid is 1 mole per cubic decimeters. They say curve 1 below represents the volume of hydrogen gas, so they're measuring the rate of producing hydrogen gas, or the rate of production of hydrogen gas. All right, so that's reaction 1. Okay, now they say curve 2 was obtained at different conditions using the same volume of hydrochloric acid. Now, what I notice is that curve 2 was obtained, or rather, curve 2 should have a higher reaction rate. So whatever change I made should form a higher rate of reaction. Okay, so let's pick an answer that would form a higher reaction rate. Now, first of all, they give me the state of division of magnesium to be ribbon. Okay, so first of all, I'm going to A and B should not be even under discussion. Why? Because the first reaction was obtained with magnesium powder. So the moment that I put ribbon there, it will actually lower the rate of that reaction. Okay, so A and B would not be options. All right, so let me look at B and C. C and D rather. So when I look at C, everything is the same as A, but it's at lower temperature. So it cannot be C because A, the first one, was obtained at 25 degrees. So when I lessen the temperature, it will lower the reaction rate. So I wouldn't have gotten curve 2. Okay, so let's look at D. It's at 30 degrees. So definitely my answer should be at my answer should be D, right? Okay, it makes sense. It's at higher temperature. Everything else remains the same as that one, but it's at higher temperature, so that should actually make sense to have a higher reaction rate. Remember, an increase in temperature increases the rate of a reaction. Right, they say in which one of the following reactions at equilibrium will they yield? Now remember, when they talk about the yield, we are talking about the products, right? They say, will the yield of the product increase when the volume of the container is increased at constant temperature? Now, please, I want you to remember, right, when we look at volume or constant pressure rather, we always say, well, an increase. And for those of you who may not understand what we are talking about, again, please just go and visit our videos on rates of reactions and chemical equilibrium, right? So when I increase pressure, remember we say that we always favor the side that has the least number of gas moles, right? So suppose I had a reaction, just making an example, let's say 2A, which is a gas, plus B, which is a gas, which should give me, let's say 2C, let's say C is a gas. This is a hypothetical reaction. What I would do is check how many gas moles do I have on the left hand side. I've got 2 and 1 here, So this would be 3 gas moles, right? But on the right hand side, where I would have 2 moles of gas. All right. So an increase in pressure here would actually favor the forward reaction. Why? Because there are less moles of gas on the right hand side. Okay. Obviously, a decrease in pressure, which means there'd be more volume, would favor the reverse reaction, because there would be, it would favor the side with more gas moles, right? So in this case, what are they doing? The change that they are making is that they are increasing the volume of the container. Remember, the moment I increase the volume of the container, what am I doing to the pressure? I am decreasing the pressure. Okay, it means that I'm making the space bigger, so I'll favor the side that has more moles of gas, right? So I want a reaction here that has bigger moles of gas on the product's side. Okay, when I look at A, I've got 1 mole of gas on the left hand side, 2 moles of gas on the right hand side, right? So when I decrease the volume, when I increase the volume, rather, decreasing the pressure, I'll favor the side that has more moles of gas. So it means that I will actually produce more NO2 in that case, because I'll favor the forward reaction. So it looks like A is my correct answer, but let's look at the other ones. Here I've got 2 and 2, so none of the reactions would be favored, forward or reverse. Here I've got 4 moles of gas on the left hand side. I've got 2, so in this case, if I were to decrease the pressure, if I were to increase the volume, I'd favor the reverse reaction, because there are more moles of gas. And for this one as well, okay, I've got 3 moles of gas, 2 moles there, so I'd favor the reverse reaction. So A definitely should be the correct answer. All right, I hope that makes sense to you. Okay, as we move on swiftly along, I hope you can see that this is quite a doable exercise. Right, so 1.6. All right, we want to know which one of the following statements is true for an exothermic reaction. So remember, when we talk about an exothermic reaction, so if you think about that graph of the energy, okay, of a reaction versus the reaction coordinates, or the progress of a reaction. So when I've got an exothermic reaction, it would look something like that. You'd have more energy on the reactant side and less energy on the product side. Why? Because it has released that energy, right? So in this case, this says, okay, for an exothermic reaction, more energy is absorbed than released. That's not true. Okay, more energy is released than absorbed. Okay, B looks somewhat true. Okay, delta H, they say reaction heat of reaction is positive. That's not true, because it's the products minus the reactants. Can you see that the products have got lower energy than the reactants? So if I took this minus that, you would get actually a negative answer. So delta H is negative. Okay, and then finally, they say energy of the products is greater than the energy of the reactants. That is definitely not true. Okay, the energy of the products is less than that of the reactants. So obviously the most correct answer there should be B. Okay, right, as we go along. All right, they say consider the equation below. All right, I hope you're still with me. They say consider the equation below, in which one of the following is a conjugate acid-base pair. Now, remember, for those of you who haven't checked out our lesson on acids and bases, please remember, for the acid-base conjugate pair, those two should actually look similar. All right, and the difference between them should just be an H plus. Okay, just keep that as a rule in mind. Which ones look similar? If I look at A, it's H3O plus and H2O. Of course, those look similar, so they should be an acid-base pair. All right. This, by the way, will spare you from having to check, oh, which one donated, which one, and all of that. But if you look at our video on acids and bases, I do teach you how to actually identify the acid-base conjugate pair, right? Please go and look at that. So in this case, my correct answer there should be A. All right, let's go to the next one. They say consider the equation for the reaction below. Okay, so they give us, this is a redox reaction. Okay, right. They say the oxidizing agent. Now, please remember, when we talk about an oxidizing agent, it's the substance that undergoes reduction. It's the one that is reduced. All right. And remember, why do we call it reduction? Okay, we call it reduction because the oxidizing number actually decreases, is reduced. Okay, so the oxidation number, so this is that number there. Now if I look at that, I see that when I come to the Cr2 plus ions, how do they change on the other side? They become Cr3 plus. No, does it look like they are reduced? That number is reduced? No, it's actually increased, right? So in that case, that's not reduction there. So it means this one must have undergone oxidation, right? So when that that oxidation number increases, so I know I've undergone oxidation. All right, but look at the SN4 plus ions. So they go from SN4 plus to SN2 plus. So it tells me that this guy was reduced. Okay, so it means that my my oxidizing agent, remember when I use the word agent, it means that it's going to be the opposite of that. Okay, so it's the one that undergoes reduction. Okay, so it means SN4 plus was the one that was reduced. So in that case, it's going to be my correct answer is D. I hope that makes sense. Okay, right, and we are almost done. Right, 1.9, they say an electrochemical cell is set up at standard conditions. Please remember, when we say at standard conditions, we know that that standard condition is room temperature, that's 25 degrees. Sorry, not room temperature, rather. It's a standard temperature, which is 0 degrees Celsius. Okay, and we know that the concentration is 1 mole. The initial concentration of your electrolytes, okay, should be 1 mole per cubic decimeters. And in this case, if one of them is a gas, okay, it should occur at 1 atmosphere. Okay, right. Okay, so in this case, they say to us the cell notation for this cell is given. So we know that magnesium should be our anode, okay, and plumbium, which is lead, okay, in this case should be the cathode, right? They say the cell is now connected in a circuit. Which one of the graphs best represents the concentration of the electrolytes after a long time? Now let's write down the net cell reaction. So this tells me magnesium should have actually undergone oxidation, so it becomes Mg2 plus, but obviously did this by giving away 2 electrons, right? I'll tell you where I'm going with this. And what about lead? It started as Pb2 plus, okay, lead 2 plus ions, they gain electrons and they become lead, okay, right? They changed in phase. Of course, we're going to take that. So our net cell reaction looks like this: Mg, magnesium, plus lead 2 plus ions become magnesium 2 plus, and in this case plus lead, which is that Pb there. Right, look at this. What happens in your electrolytes? The lead 2 plus ions are going to be used, so what would happen to them? They should actually decrease, whilst in this case what's going to happen to magnesium? You are producing it, the magnesium 2 plus ions, you are producing them, so they should actually increase, right? So this tells me over time, okay, magnesium 2 plus is going to increase, okay, and lead 2 plus ions, okay, are going to decrease. So which graph speaks to that? All right, so I see that graph there. They start at 1 and they increase, and those ones decrease over time. So I would go with option C. Okay, right. I hope that makes sense to everyone. And we look at the final answer now, the final question rather. Of course, just please note, ladies and gents, that fertilizers will not form part. And I remember there was an errata that was sent on this question. I didn't manage to prepare that on time, but nonetheless, this is for all those future students who will be looking at this video. Okay, for those of you who are in Matric, that is, who are going to be writing the grade 12 exam, please remember that fertilizers has been removed. Okay, it's been trimmed out. Okay, but nonetheless, I will answer this question. So they say 2 bags, 250 kilogram bags of fertilizer, R and S respectively, are labeled as follows. They say fertilizer R. Okay, okay, that's got an NPK ratio there. Okay, 315, and fertilizer S, okay, with 1 to 5. They say identify the fertilizer most suitable for healthy leaf growth and healthy root growth. Okay, so if I look at that, for healthy leaf growth, I would have taken fertilizer R. Okay, not only it's got a bigger ratio. Okay, so if I look at that ratio there, it's going to be 3 over, what's 3 plus 1 plus 5? That would be 3 over 9, right? In terms of nitrogen, you need nitrogen for that leaf growth. Okay, so this has got a better nitrogen ratio or component. Okay, big amount of nitrogen. And then for root growth, I would look for something that has more potassium, right? So in this case, I would go with the fertilizer S. Okay, that's better for root growth. So it's got more potassium in it. Okay, so in this case, I would say R would be for leaf, and S would be for root. So in this case, R and S. So my correct answer there should be C. But obviously, as I did say, for those of you that are in grade 12 this year, all right, please remember that we will only get up to, we will not be examined on this section. Okay, right. Thank you so much, ladies and gents. I hope that you found this quite helpful. All right, and I'll see you guys again next time. Please don't forget to subscribe. And yeah, final exams are coming very soon. So please look out. I'll be doing some live sessions as well. Okay, hopefully we will be able to benefit from those. And please just make sure that you continue to work hard and, just do your absolute best. All right, I'll see you guys next time. Sharp, sharp.